So we'll continue with the exercise problems. That is the second exercise of the triangle. We had done few problems in the previous video. So let's continue. So in the previous video, we had solved up to sixth question. We'll start from the seventh one. So using theorem 6.1, prove that a line drawn through midpoint of one side of a triangle parallel to another side bisects the third side. Okay. This is basically the converse of midpoint theorem that we are going to prove it. Okay, using theorem 6.1, that is the first theorem, BPT theorem, right? So using BPT theorem, we have to prove that a line drawn through midpoint of one side of a triangle parallel to another side bisects the third side. Okay, now this is the seventh one. So what we have to do is, let's take a triangle A, B, C, and let's take midpoint of one side. Let's say D is midpoint. Okay, meaning the value of AD is equal to DB. From this midpoint, I'm drawing a line parallel to one side, and the point where it meets, let me take it as E. I have to prove that E is midpoint. Basically, I'm drawing a line in such a way that D is midpoint. If D is midpoint, we should also prove that E is midpoint. Okay. So what is given? It is given that in triangle ABC, D is the midpoint of AB. If D is midpoint, it implies AD will be equal to DB. Okay. And they've also given that DE is parallel to BC. DE is parallel to BC. What should we prove? We have to prove that E is also midpoint. E is the line drawn through midpoint. This is the midpoint. We are drawing a line through it, parallel to one side. Wherever it meets, it bisects the side and it divides into two equal parts, right? Bisect the side in the sense it divides the side into two equal parts, AE and EC. Meaning I have to prove E is midpoint. E is midpoint of AC. That is, I have to prove AE is equal to EC. If I prove AE is equal to EC, then we can tell E is midpoint. Okay. So coming to the proof. Now, in triangle ABC, DE is parallel to BC, isn't it? It is given. Therefore, we can use BPT theorem. Using BPT, we can write AD by DB is equal to AE by EC, isn't it? Now, instead of AD, I can replace it by DB, isn't it? DB by DB is equal to AE by EC, because AD and DB are equal, isn't it? Therefore, DB gets cancelled. You are left with 1 by 1 is equal to AE by EC. Cross multiply it. 1 into EC is EC, 1 into AE is AE. So therefore, you got EC and AE are equal. If this side and this are equal, then E should be midpoint. Implies E is midpoint of AC. Okay. So very simple one. The line was parallel to one side of the triangle, so we use BPT. Since D is midpoint, AD and DB are equal. Take out AD and replace it by DB. Gets cancelled, cross multiply, you will get the answer. Okay, this is the seventh question. Similarly, we'll solve the eighth one. Using theorem 6.2, that is converse of BPT. Using converse of BPT, prove that line joining midpoints of any two sides of a triangle is parallel to third side. Okay. So what we have to prove in a triangle, this is eighth question. In a triangle, let's take a triangle A, B, C, line joining midpoints of any two sides. Let's take AB and AC. Let's take midpoint D is midpoint, E is midpoint. So let me join these two midpoints. We have to prove that line joining the midpoints, that is DE, is parallel to BC. We have to prove this DE is parallel to BC. So what is given? It is given that in triangle ABC, D and E are midpoints. It is given in the question itself. So D and E, first let's mention the triangle. In triangle ABC, D and E are midpoints of AB and AC respectively. If D is midpoint, what does that imply? It implies AD is equal to DB. Similarly, AE is equal to EC. If it is midpoint, we can write it like this. Okay. What should we prove? We have to prove that DE is parallel to BC. We have been discussing this. If I want to prove a line is parallel to one side of a triangle, what should we do? We have to prove that the ratios are equal. If lines are parallel, ratios are equal. If ratios are parallel, lines are if ratios are equal, lines are parallel. I'll repeat it again. If these two are parallel, ratios are equal. If ratios are equal, lines are parallel. Okay. So let's find the ratio AD by DB first. AD by DB, that is equal to, instead of AD, I can replace it by DB, right? So both gets cancelled, you'll be left with 1. Okay. Similarly, AE by EC, instead of AE, I can write it as EC because both are equal. So both gets cancelled, 1. So both the ratios are equal. AD by DB is also 1. AE by EC is also 1. So both are equal. Since the ratios are equal, therefore, DE is parallel to BC using converse of BPT. So using converse of BPT, we can say that the lines are parallel because the ratios are equal, isn't it? Therefore, the lines are parallel. Okay, let's solve the 9th. ABCD is a trapezium. ABCD is a trapezium in which AB is parallel to BC and its diagonals intersect each other at point O. Show that AO by BO is equal to CO by DO. Okay. So this question, 9th one, we can actually do it in a very, very simple way once we learn the concept of similarities. Okay. Let's also do it here. But the same question can be solved in a very, very simple manner once we finish the concept of similarities. Okay. So what we have got is, we have got a trapezium ABCD. So what is a trapezium? Trapezium is a quadrilateral, meaning it is a four-sided closed figure in which only one pair of opposite sides are parallel. If both the pair of opposite sides are parallel, then it is called as parallelogram. If only one pair of opposite sides are parallel, then it is called trapezium. Something like this. Let's take a trapezium like this. This is a trapezium. Very clearly, if you observe, AB and CD are parallel to each other. But these two things, AD and BC, if you extend it, they will meet somewhere. Okay. So therefore, only one pair of opposite sides are parallel. So therefore, we call this as trapezium. In this trapezium, the diagonals intersect each other. The diagonals intersect each other at O. So this is the given thing. So what is given? It is given ABCD is a trapezium. ABCD is a trapezium and AB is parallel to DC. So what should we prove? We must prove that AO by BO is equal to CO by DO. This is what we have to prove. Okay. Now, let's make a small construction. Why construction? Because, see, we want to prove the ratios are equal, right? So either it should be by BPT or converse of BPT. Now, if I want to use BPT, I should have a triangle in which there should be a line parallel to any one side. So you got a triangle here, but is there any line which is parallel to one side of a triangle? No. So I'll make a construction in such a way that let me draw line from O to AD in such a way that that line should be parallel to DC. Okay. So draw OE parallel to DC, which implies if OE is parallel to DC, OE will also be parallel to AB because AB and DC are parallel, which implies OE is parallel to AB. Because AB and DC are parallel, right? Therefore, OE will be parallel to AB. Now, let's focus on the triangle ADC. In triangle ADC, okay, let me erase this part for our reference and for our better understanding. Let's erase this. I'm taking this triangle, okay, ADC. In that, OE is parallel to DC. OE is parallel to DC, isn't it? Therefore, if I use BPT now, I'll be using BPT. We get AE by ED is equal to AO by OC, or I can write AO by CO, equation 1. Okay, let me draw it back. Okay, why did I choose this triangle specifically? Because in this triangle, I will get AO and CO. That is the reason that I've chosen this. Now, similarly, I want BO and DO, right? So I'll take this triangle DBA. Let me erase this part now. This triangle. In triangle ABD, OE is parallel to AD using BPT. Observe. I'll start from here. AE by ED. AE by ED will be equal to BO by OD, or I can write it as BO by DO, equation 2. So from 1 and 2, I can tell that AE by ED is equal to AO, sorry, from 1 and 2, LHS are same, therefore RHS are same, right? So AO by CO is equal to BO by DO. Now what I'll do is I'll just swap the places. See, just observe. I'll just swap it. We can do that. Okay, I'll just interchange the places. Or in other words, let me cross multiply it. AO into DO is equal to BO into CO. Now what I'll do is I'll get this. This is in multiplication. So I'll get it this side. It will become division. This is in multiplication. I'll send it the other side. So you'll get AO by BO is equal to CO by DO. Isn't it? I kept it this as it is. BO came this side, transpose this side. So it went here. DO went that side. So CO by DO. In other words, in a very simple manner, I can say that I have swapped the positions. CO here, BO here. That doesn't make a big difference. Okay. Therefore, we have got AO by BO is equal to CO by DO. But once we have finished the concept of similarities, the same question can be done in a very, very simple manner. If the same question is asked in the exam, we could do it in the using similarity of triangles. Okay. End question. The diagonals of a quadrilateral ABCD intersect each other at the point O such that AO by BO is equal to CO by DO. Show that the ABCD is a trapezium. This is exactly the reverse of what we did. ABCD was a trapezium. We proved that AO by BO is equal to CO by DO. Now they have given AO by BO is equal to CO by DO. Now we have to show that it is a trapezium. Okay. So let's take a quadrilateral. Okay. Since we have to prove that it is a trapezium, I'll draw it in the shape of a trapezium itself. Okay. Let me draw it in the shape of the trapezium. But I cannot say it as a trapezium because it is just a quadrilateral now. Okay. If I want to prove this is a trapezium, then we have to just show one pair of opposite sides are parallel. That is enough. If I show one pair of opposite sides are parallel, that is from the figure, if I show AB and DC are parallel, then it becomes a trapezium. Okay. So what is given? It is given that and the diagonals of the quadrilateral. Remember, this is a quadrilateral. It is looking like a trapezium because we want to prove it is a trapezium, right? That is the reason that I've drawn it like that. But it is actually a quadrilateral now. Okay. Eventually, it's going to become a trapezium. So it's a quadrilateral, okay, in which the diagonals intersect at point O, and it is given that AO by BO is equal to CO by DO, and we have to prove that ABCD is a trapezium. That is I dot E, that is AB is parallel to DC. This is what we have to prove. Okay. Now, what we'll do is we'll make a construction, that is, let's take a line. Let's draw a line EO which is parallel to DC. Okay. Construction draw OE parallel to DC. Earlier in the previous question, when I drew like this parallel, automatically this became parallel to this because it was trapezium. These two were already parallel. Okay. But we don't know now. Now, whether they are parallel or not, we don't know. We have to prove that they are parallel. So I'll draw a line EO parallel to DC. This is what we have drawn. Okay. Now, I'll take triangle ADC now. In triangle ADC, OE is parallel to DC, isn't it? OE is parallel to DC. Therefore, using BPT, the same logic that we used, AE by ED is equal to AO by CO, isn't it? Let's take this as equation 1. So you have just taken this triangle ADC. This line is parallel to this side. Let me erase this. So I can use BPT. I get AE by ED is equal to AO by OC. Okay. Now, observe, it is given that AO by BO is equal to CO by DO. It is given, right? It is given in the question. As I told you in the previous question, that we can swap the places, right? The numerator and denominator, we can just swap it. Okay. But you cannot swap the numerators and numerators. Numerator and denominator, you can just swap it. So AO by CO is equal to BO by DO. Let's take this as equation 2. Now compare 1 and 2. From 1 and 2, observe carefully. AE by ED is equal to AO by CO. But that AO by CO is equal to what? BO. This is equal to this. But that is equal to BO by DO. Which means these two are equal. From 1 and 2, AE by ED is equal to BO by DO. Okay. Now, if you take triangle, let me write it here. In triangle, let me take the other one, ADB. We can write this because just now we have proved it, right? AE by ED is equal to BO by DO. Proved above. We have just proved this. Now observe what is happening. Now let me erase this. Observe what we have got is, we have got that AE by ED is equal to BO by DO. So the ratios are equal. Therefore, the line should be what? Parallel. Implies EO is parallel to AB. This is converse of BPT. Isn't it? Using converse of BPT, we can say that EO is parallel to AB. But EO was, or let me write it as OE because I've taken OE here. Already OE was parallel to DC. Now OE is also parallel to AB. It implies AB is parallel to DC. If AB is parallel to DC, what type of figure it is? It is a trapezium. So it's a very, very simple thing. Let me recapitulate it. So we had a quadrilateral like this. What is the construction we made? We drew OE parallel to DC. Therefore, you use BPT, we got this. From the given data, we got this. Comparing, we got this. That is AE by ED is equal to BO by DO. So that is actually the ratios are equal. Therefore, the lines are parallel. EO is parallel to this. So EO is parallel to this. EO is also parallel to AB. Therefore, these two become parallel, which implies that it is a trapezium. Thank you, students.